Let's look at the solution for question 3. There have been many queries concerning this question. It looks rather complicated, but as you will see, the solution is quite straightforward. In the first part of the question, you are told that there is an arrangement for loading of solid liquid fluid mixture, which we call slurry, into railway wagons. The nozzle here delivers 0.5 cubic meter per second of mixture of a density of 2000 kilograms per cubic meter in a direction along the line of track. So it's along the line of track, but at an angle of 30 degrees to the horizontal. The wagon is moving at 5 meters per second. The jet has a velocity of 15 meters per second relative to the ground. So very similar to question number 1. In our solution, we have to work on relative velocities. We have to apply a stopping velocity -5 to stop the wagon. As a result, the mixing velocity has to be adjusted. That is really the only thing you need to be careful. We are really talking in terms of relative velocities. Okay, so what we need to now do is to show that the force imposed on this partially filled wagon, we are not told much about what is happening in the wagon. We are just told it's partially filled, okay, and purely rolling motion caused by the jet striking the free liquid surface of the slurry. Okay? Now, if we look at the solution for the first part, the mass flow rate is the velocity, the volume flow rate multiplied by the density of the slurry, which is 2000 kilograms per cubic meter, which is 1000 kilograms per second. The component of the velocity of the jet in the x direction is 15 cos theta. We are looking for the horizontal component. But remember, we have to consider the relative velocity of the wagon. So what we do is we apply a stopping force of 5 meters per second. As a result, the velocity of the mixing jet also has to be slowed down by the same amount. And this is the important point. The velocity relative to the wagon is 15 cos 30 minus 5. Now that's really all that we have to be careful about, because we now apply Newton's second law for momentum onto the control volume. The force Fx is V out minus V in multiplied by the mass flow rate. Now we consider in the x direction. So if we plug in all the values, leaving is nothing, entering is, as what we have said before, 15 cos 30 minus 5 times the mass flow rate, we get minus 8,000 newtons or 8 kilonewtons in the opposite direction. The force on the wagon. Remember, the minus 8,000 is the force on the slurry, and it acts by Newton's third law, 8 kilonewtons. Okay, now let's pause here for a while to reflect on this solution. Let's continue. Remember, we have only done the calculation for the horizontal component. Let's now consider the vertical component, because the vertical component adds to the vertical force having a tendency to press down onto the track. We need to find the resultant force, so we apply Newton's second law to the control volume in the z direction, exactly the same. Velocity leaving outwards in the z direction. Remember, we have defined the z direction as positive down, going in, and we get a value of minus 7,500 or 7.5 kilonewtons, resulting in a magnitude, when we compound the horizontal and vertical forces, as 11 kilonewtons as a tangent of 7.5 over 8, tan inverse, below the horizontal. Okay, this is shown in the little sketch by the angle theta. Let's continue with the solution. We are now told that this carriage or wagon moves to another section where there is a cleaning nozzle. If you look at the nozzle, now the cleaning nozzle acting on the railway wagon, you can see that the angle is the same. We are told that the wagon is filled. Incidentally, the weight of the wagon doesn't come into the relations because we are dealing with the momentum force and rolling friction, essentially. Let's continue with the second part of the solution. In this case now, we do not know the velocity of the water jet, the cleaning jet. Let's give it u meters per second. Since both nozzles, the mixing nozzle and the cleaning nozzle, have the same flow area and the same volumetric flow rate, if we know the velocity is 15 meters per second for the mixing nozzle, then we can find the area of the nozzle. So now we consider the change of momentum in the horizontal direction only. Okay, and remember there is a hint that the horizontal force imparted on the truck by the water cleaning nozzle must be the same to maintain the force. So u cos theta minus 5 multiplied by the mass flow rate. Okay, let's review. This is the area, this is the velocity. Area times velocity gives you the volumetric flow rate multiplied by the density of water, and the force must be the same to maintain the speed. So we end up with a simultaneous equation in u squared, quadratic, sorry, not simultaneous, but a quadratic equation in u squared, which simplifies to this. It cannot be factorized easily, so we need to use the solution for a quadratic equation, and we get a value of 19.8 meters per second. Okay, if we look at the quadratic, minus b plus or minus b squared minus 4ac over 2 times a. That is the formula for solution of a quadratic equation when you can't factorize it. And you get 19.8. We ignore the negative sign. Okay, all negative solutions for velocity are ignored. This ends the solution.